Let's consider the following scenario. We have this point A that can move around this circle that is inscribed inside of a square. And we'll assume that this circle has a radius of 3 centimeters. Let's think about the distances that are marked here by these the blue and the red vectors. So if we drew a vertical and horizontal diameter through this circle, then this looks kind of familiar. Looks like a similar context. So if this angle has a measure of theta radians, we know how the position of A relates to the center of that circle, or the vertex of the angle. So more specifically, this point A's distance to the right of the center of the circle, which again, I'm just representing this distance right here, that is cosine of theta radius lengths. But each radius length is 3 centimeters long, so it's 3 times cosine of theta centimeters. And so point A is 3 times cosine of theta centimeters to the right of the center of that circle. So if that represents that distance in centimeters, we actually know that this distance right here is 3 centimeters. Because that distance is really just the radius of the circle. If you imagined moving that segment down, that's really just the radius of the circle, which is 3 centimeters. So if you combine the 3 centimeters plus the 3 times cosine of theta centimeters, we end up with that entire segment that is now kind of hidden by my drawing. That's going to be 3 plus 3 times cosine of theta centimeters long. So if you imagine combining those two things together, the total length is 3 plus 3 times cosine of theta centimeters, and therefore point A is 3 plus 3 times cosine of theta centimeters to the right of that left side of the square. Now, in a similar way, we could actually break this vertical one up into 2 pieces. That one right there, that actually has a fixed length, and then this upper red vector that represents point A's distance above the center of the circle. So in a similar way, we could talk about point A's distance above the bottom side of that square. And if we put those two things together, you can actually imagine drawing in a right triangle here. So you imagine this right triangle. The length of that vertical side is point A's distance above the bottom side of the square. The horizontal length is really just that horizontal distance to the right of the left side of the square, and the hypotenuse length will give us the distance between points A and B. So if you use the Pythagorean theorem and use the lengths of the two sides of that right triangle, you can actually determine how far point A is away from point B for any angle measure theta.